Hello everyone. This is the second crash course in the Linux Forensics series. This video is about Linux file system analysis. It involves examining file systems to uncover evidences and understand the behavior of systems and users. This crash course is designed for beginners, but you need to have some basic knowledge of computers. It takes a lot of time and efforts for me to build such content. If you find this useful, please don't forget to subscribe this channel. Let's get started. All right, so now let's first learn what are the content in this crash course. Okay, first we are going to learn about what is Linux file system analysis, how exactly it is formed, what's the objective of it, right? And then we will learn what is Linux file system in the very first place, right? We will learn about different directory structure, how they are organized and everything, right? Then we will get started with the exercises. We will learn about listing and understanding directory content, and this involve using some native Linux native tool. And the exercise 2, we are going to analyze the file metadata. We are going to analyze the information about a file, or additional information about a file or a directory maybe. Okay, this next we are going to talk about exercise 3, which is the disk usage analysis. From forensic point of view, this is very important because you will understand which file is consuming more amount of space. And this is very very important from forensic point of view. You understand which is suspicious file, or which is maybe used for any malicious purpose, which might consume more storage than expected, right? Exercise 4 is going to cover searching and filtering file content. We are going to learn how can we use certain Linux inbuilt command or tools or utility tools to search for all the files having a specific string inside, or maybe a specific keywords, right? And finally, we are going to conclude our crash course. All right, so now let's learn about what is Linux file system analysis. Okay, so now Linux file system analysis is a process. It's a process of examining the structure and the content of file system. Okay, content of the files in the Linux. Okay, the purpose is to uncover and to analyze and interpret the digital evidences. Okay, artifacts. So the purpose of the entire Linux file system analysis, to summarize, is to reconstruct the event, to see what happened in the past, and find the user activity, to identify the security breaches if happened in the past, and to recover the deleted data. Okay, this is needed in case of a dedicated digital forensic activity when you lost your data. Okay, as a part of DFIR activity, digital forensic and incident response, we don't do a lot of things related to this, but we might have to do it. It depends on the situation. Other than we ensure compliance as well. Now to gather the evidence, now to gather the evidence and to analyze the data, it's also part of the legal investigation process, and of course incident response process as well, right? So now let's understand different activities involved in the file system analysis. Okay, this involved first activity is about file and directory analysis. File is simple file, and directory is like folder, right? So this involves activity related to identifying and analyzing files, directories, and their attributes. Attributes is like their related information, right? It's also involve activity related to timestamp, when the file was created, when it was last modified, examining the mac time, modification, access, change time. In short, we call it as mac time. Okay, to understand the timeline of file activity, and also to find any hidden file as well in the network, right? Usually whenever the malicious files are created, or checkpoint files are created by the malicious actor or hacker, they tend to do it tend to create hidden files most of the time, which might contain some crucial evidences as well. Second, we also do metadata examination as well. Now, metadata is all about additional information about the file related to, of course, as I said earlier, when the file was created, what are the different, structure of the file, where exactly it is being stored, who is the owner of the file, what's the group of the file, and everything related to that, right? Now, next is the file content analysis. This is also very, very important. We have to, let's say, as a digital forensic analyst, we know that there can be hacker or a malicious actor might create multiple files on your system, or maybe a malware itself might create multiple file, and they might have, all the files might have this specific keyword, let's say trojan, like, right? Or maybe malware itself, for example, right? Of course, malware shouldn't be, will not be there, but for example, malware is there on all the files. So I should be able to search all the files that has this keyword, maybe trojan, or maybe malware, or maybe 64-bit, or anything related to that, or maybe encryption, AES 256, right? So I want to search all the files that has this specific string or a keyword inside, right? So that's all about file content analysis. We might do the advanced activities as well. It depends on the situation. Of course, in this crash course, we might not be doing that. But remember one thing, we might require to do a advanced activity for which we require advanced tools as well, right? So this activity could be data recovery. This activity could be related to malware detection. I'm not saying with our basic activity, file system analysis activity, in the beginner level, we cannot find a malware or identify malware, but it's still on the basic level. Okay, in the real world, engineers use third party tools, right? There are multiple third party tools available which can be used. Now, other could be advanced tools like Wireshark, which is used for analyzing the network traffic as well, which we can definitely talk about in the network analysis as well. But this is more related to file system analysis. Okay, so this is more about the advanced activities. All right, so now let's talk about Linux file system. Well, Linux file system is a structured way to store and organize the data in the disk drive. It's that simple. Just like you store your book in different shelf, right? So that you can keep it properly and you can, pick a specific book easily. So that's the entire job of file system, or for example, a database, right? In the real world, we uses multiple databases. So we uses different tables to store different data, maybe your username and password, so that retrieval can be easier, right? And that's what it is. It manage how the data is stored, retrieved, and organized on a storage medium. Perfect. Now there are different types of system storage, the way you actually organize your information, right? So it can be organized by using ext2, which is widely used file system, known for its reliability, performance improvement. Uh, and we also have 3 and 4 as well, right? Now, we also have XSF. It's again a different type of file system. I'm just taking, for example, it's high performance file system. It's good for a large file size. Okay, large file size or high capacity storage devices. Now, if you talk about BTRF, so this is a very modern file system, which is good if you want to go for snapshotting, some advanced features like self healing or RAID system as well altogether. Now, there are different structures when you organize your files in Linux or your data in Linux. Okay, so it is super block, inode table, but let me start from the back. Okay, so metadata is like additional information about your data. And directories, I hope you know it already. Directories like your folder, right? You save your data into it. But data block is the actual unit of storage that contains your actual data of file. It's too much actual, but it's okay. Each file's data is spread across one or more data blocks as well, so it's overlapping situation, but it works, right? And I know table is like your collection It represent file and directory, and but it's different attributes as well, it different metadata as well. It represent the actual file plus your metadata, or you can say data blocks as well, right? So it also includes your data block and your metadata or the actual files, right? Finally, super block. Now super block contains the metadata about the file system, and size, block size, inode count, everything, and also any block as well. So it's like superset of all representation. Okay. Now, let's talk about different directories, and we will talk about it from the forensics perspective. Forensic perspective. What I'm saying. Okay. Anyways, now we first on the top we have slash. This is the root directory. Okay, this is the top level directory of the Linux file system hierarchy. The importance is it's from forensic point of view. It's basically a starting point. Okay, there is no specific importance from the forensics point of view, but it's very general. From this, all the directories basically starts. Okay, let's first talk about the bin directory. Now, this contains the information about binaries, which are executables, right? So this is where the programs or new, programs or codes are actually saved. Okay. So, as a forensic investigator, we can check the integrity or modification of any binaries, which could lead to any tampering or rootkit as well, right? Next, we have boot. Now, boot is a boot directory slash boot directory contains the bootloader that includes the information related to the kernel. Okay, so if there is any sort of changes into it or anybody modified any information, we as a forensic analyst will look for any evidences or compromised bootloader or unauthorized kernel modification as well, right? Next, we have dev. Now, dev contains the device information for hardware devices. Okay, so as a forensic investigator, we can check for any suspicious device file which could indicate malicious hardware, interaction. I would say not the hardware, but interaction, or maybe any hidden data storage into the system as well, right? Next, we have etc. This consists of configuration files. So whenever you install any software into the network, there will be a configuration file created, right? Those will be stored usually in etc. Even all the pre-built configurations are also stored here. As a forensic investigator, it is our job to see if there is any configuration changes happen, so we can do that, or maybe user password also are stored here. So etc slash pass wd, this consists of user password, or slash etc slash shadow, this consists of user and password. So if a malicious actor has added any new user and password, you can come here and see that. You can also see the host information, network information at etc slash hosts. Okay, or maybe slash etc slash network, if I'm not wrong, network and then interfaces. Okay, I suggest you verify this. But yeah, this is where you can verify the network configuration. Next, we have hope. Now, this is where the personal directory informations are stored for every user. Let's say I I I set up my own Linux system, so I might have my own directory, right? So with slash home slash Rajneesh, right? So this is where all of my relevant information will be stored. Maybe my activity, my preferences, browser activity, or all those, or maybe my downloads or personal data, all will be stored here. Okay. Next, we have root directory. Now, root directory is the home directory for the root user. So, as a forensics investigator, we always should look at these files because this contains the root user configuration file, log file, personal data, and it's very important to examine this super user activity. Next, we have run as well. So run contains the runtime data for the system processes, maybe temporary file related to system state, running processes. So for that, we can evaluate this. We also have as bin. Now this consists of essential system binary for administration, like fconfig, utility information. So as a system admin tool, it's a system admin tools, which if modified could indicate privilege escalation attempt as well, right? Now we have temp. Now it represents the temporary files. Now next we have USR, user. Okay, so this consists of user programs, libraries, documentation, and source code. So we, as a digital forensic specialist, we always should keep an eye on it, because this consists of user install application and utility as well, right? And then we have var sorry now then we have var consists of different logs related to the contains the variable data files, or including logs or databases, websites related information as well. So this is where you will be having slash var slash log, right? So this consists of all the log information of the system. Okay, or maybe for web application you can always come to slash var slash www, right? So this is where web server files will be stored. Okay, and the moment you want to see any logs, you just visit slash var slash log. This is where you will find all the system related logs. Okay. All right, so now let's talk about exercises. This is my GitHub repository. I'll share you the link in the description. This is the project. This is the home lab, basically, on file system analysis, Linux file system analysis. And there are list of exercises. This is on beginner level, as you can see. And let's start with the exercise one now. Okay. This is listing and understanding directory content. Okay. So it's going to be really, really simple. Most of you might be knowing this already. The first thing that we need to do to see all the content inside a directory is ls. It's that simple. You hit enter, you see all the files inside. Okay, if you do ls minus l, you see that in detail. First you see all the file permission. This gives you the file permission. R represent read, w represent the write, and then you also have certain different characters as well. Now if you see d somewhere, that represent it's a directory. Okay, and if you see c, so that means it's character. And there could be some more, but we won't go much deeper inside. Let's talk about this represent the number of links. So we have one, that means there is a number of hard links to any specific file. Okay, and this represent to a owner of this file. Currently the owner is root itself, and this represent the group of this file, which group a group name of the files basically belongs to. Okay, next we have file size. This represent the file size. Okay, as you can see, this entirely represent the last modification date, last modified time. Okay, finally this is our file name. Perfect. So this is the most simplest command. Let's go slightly more deeper. If you want to, as a digital forensic specialist, if you want to see, or as a dfir engineer, if you want to see any hidden file inside which is not clear with the ls minus l command, you can use ls minus la and hit enter. Now you see even some hidden files as well. You can see more file than before, right? These are all hidden files. Now you can also be very specific about certain directory. Let's say home, so you can see the home directory hidden files as well, right? All right, so exercise number 2, analyzing file metadata. What is metadata? Metadata is basically the data that describes other data. It's an additional information about every data, every file, every directory, anything. Okay, so to get the metadata about any file or any directory, we'll be using a command called stat. Now, stat is very powerful, which gives us the information about the file or the file system. This command gives information such as size of the file, access permission, user ID, group ID, birth time, everything. Let me show you practically. Let's say we take any file, for example, let's say unwanted.exe. Okay, and we can use a stat command. And before we even use it, let me show you different options available. You can run stat help, and you can see all the options and parameters. That these are tons of options. You see this, right? So let's keep it very simple. Let's run stat and the name of the file, unwanted.exe. The moment you hit enter, you will get all the information from file name, size, blocks, this information about the structure, file system structure. And then you get the information about the device, inode, links, access, privileges basically, and when it was last accessed, this specific file, when it was last modified, the change, when the change was done, and the birth of the file, right? This is plenty of information, right? Let's clear this up. The next command that I'm going to talk about is very interesting from a digital forensic perspective as well, because you might have to search for some suspicious file in the network. Some IOCs called indicator of compromise. Now you want to search for that specific file in your forensic data or a system. So what you can do is you can use a find command, and then you can search for a specific string. Okay, or maybe let's say I want to search for a specific type of file, maybe extension of file, maybe .exe. I want to see all the exe files in this specific directory, in my current directory itself. Or maybe I can specify the directory name by /home maybe. Okay, but I want to see all the .exe file in my current directory. Let's hit enter. Oops, I don't see that. It's because I haven't used a wildcard entry. So wildcard entry makes sure that I see all the files. I mean, whatever is there before this dot, I don't care. So I want to see all the file which ends with .exe. Let's hit enter and we can see this. Perfect. So this gives us all the files ending with .exe extension. Okay. Similarly, we can also get all the empty files as well in the network. Empty files are very important as well from SOC Analyst, and because this is automatically created by the advanced threads as well, for multiple purpose, for malware analysis, for as a checkpoint, as an indicator as well. So what you can do is you can search for all the empty file in a specific directory, or maybe in the current directory. Let's say you do the minus empty and you see these are all empty file. Or you can even search in a specific directory, in a specific directory as well. Sorry, give me 1 second. Home empty, right? So you see all the, these are all the empty file in the home directory. Perfect. You can also do quite a lot of other stuff. Okay, you can also find all the files by size. So all the files which is size more than 100 MB, so you can see all the files here. And next, you can also find the files which is modified in maybe last 7 days. So let me show you that. Let's say I search for fine in the same directory, so I don't want to go for directory especially, so I'll search for file. So minus type f and m type. I want to see all the file modified in last 7 days, so I'll say -7. Let's see. Perfect. These are all the files which were modified last 7 days. All right, so now I'll leave other tasks for you to complete in this exercise too. So complete all the other tasks yourself, and give me the confirmation in the chat or in the comment section below. Write it down, exercise 2 completed. I would love to see that. All right, so now let's move to the exercise number 3, disk usage analysis. You might wonder, what's the purpose of a disk usage analysis for a digital forensics activity or incident response? Well, in the real world, when there is a suspicious activity happening, there might be some files which might be consuming, which might be having quite a lot of data inside, or there could be some folders or some directories which might be having a lot of data or heavy files inside. So in that case, this command or this activity can be really helpful. We are going to use df command, which is used to identify the disk space utilization. Okay, so first of all, we can run df minus h command. This will give us the disk usage in human readable format. Okay, you can see these are all the disk, and this gives us the disk space usage of all the mounted file system. These are all the file system and their corresponding utilization. Okay, you see this is not really utilization, this is the absolute size, and this is the used size, and this is the available size at this moment. Only 2% of the file system is currently being utilized. Okay, so this is the current state that we could see. From here also, as an engineer, as a security engineer, we can get the idea which file system is having more data inside, so we can be very focused on those situations. Let's move to the next step, where we can try to identify, if let's say we have an idea that this is the specific directory I want to look at, and there could be hundreds of files on each directory. What we can do is we can run du minus sh, and we can be even specific about certain directory. We can go hop into multiple directory and understand if this directory is having more data inside or not. It's just 52K, it's very low, right? We can even look at other directory, root, 56K, very low. Similarly, we can also go to var/log, where the logs are stored. So we can see it's 110 MB. That's huge. And that's obvious because /var/log stores all the logs. You see, if I run /al/var/log, okay, this will show me all the logs, from kernel logs to system logs, syslog logs, UFW logs, everything. So this is pretty much obvious, right? But if I see a lot of data in the home directory or user directory or any etc directory, which usually have configuration, so if it is really high, so I have to be really worried on those situations, right? So this is very, very important for every activity. You can also use a du command as well. This will give us the disk the usage of every file and directory within the specified path as well. So for example, we can run du minus ah, and then we can specify the home directory. Now this gives me the usage of individual file. You see this, all the individual file, ransomware.txt is 0, right? Malware.txt 4K. So this is also very useful. I hope you got the idea. All right, so now it's time for exercise number 4, searching and filtering the file content. Okay, for this, we are going to use grep command. It's very powerful. Usually in the real world, we uses a lot of cool tools like we have Yara. If you want to search for any specific string in a malware sample, but as a part of file analysis, grep is very powerful, very quick. Okay, so we can definitely use it. So let's say we know that a specific set of files might consist, or I want to search for any file that has a password written inside. Okay, so I can use grep command, just like I have shown in the example as well. So I can run grep command, and then the search string, for example password, and then list of all the files. Okay, the way you can do it, or either you can type all the individual files, or you can use a wildcard entry. Okay, and give your extension. That's a smartest thing. You can also specify the directory within it will search in that specific directory. But if you want to do it in your current directory, you just specify wildcard entry and the extension. Okay, I would like to search for a specific string called malware. Okay, and I see these files having malware written inside. You see this malware.exe. Let's open this file and see. Perfect, it's there, right? So of course I have written that. But now you can even verify this one, unwanted. Okay, so unwanted.exe, you can see there's quite a lot of stuff written, and this is malware is also written in here, right? You can also perform recursive search in the directory. In case, let's say you just want to enter the directory, and you want to let you are not sure about the extension of the file, right? You just want to specify the directory and let the grep search for the keyword in all the files. For example, grep minus r, and then I'll just mention malware. Okay, and let's see the result. Right, perfect. We have more results now. So even script.doc also have malware, but it has doc extension. That's why we didn't see that earlier, right? We have unwanted. It was already there, right? So these outputs were already there. But with this, you can only focus on a specific extension or a set of file. But with this, you can look for all the files in a specific directory. Okay, you can go for home directory. Similarly, I don't have any files having malware as as a keyword inside or string inside, so I don't have any results. Perfect. Right. So now third thing is you can also find the occurrence of a string. So what I can do is I can search for minus C, the count, it will count that string in a file. So malware, and then I can search in the directory or probably all the extension, all the file having .exe as the extension. Let's hit enter. Perfect. This is the occurrence. Command .exe is having malware keyword once. Unwanted is having malware keyword only one time, and urgent is only also having count as one. Okay, so that's how you can find the occurrence of a specific string as well. All right, so I hope you have enjoyed this video on Linux file system analysis. If you have any question, let me know in the comment section below. Bye for now.